Why can a stream of water cut steel without melting it? Most cutting methods rely on heat, glowing metal, sparks, burned edges. But a water jet wins with something totally different: pure speed and microscopic impacts, not temperature. Here's the answer in one line: water jet cutting is erosion, not melting. Think of it like upgrading a pressure washer into a precision sandblaster. Instead of heating metal until it flows, a water jet chips it away, grain by grain, while the water constantly steals the heat. A water jet starts with a pump that pushes water to extremely high pressure. Then the nozzle turns that pressure into velocity by forcing the water through a tiny opening. The stream becomes a needle-thin jet that hits the material so hard it behaves like a cutting tool. Pure water alone can cut softer materials. But metal is different. So for steel, titanium, and hard alloys, we add abrasive, often garnet. At that point, it's not really water doing the cutting. Water becomes the delivery system that accelerates abrasive particles into a high-speed cutting swarm. Inside the cutting head, the fast water stream creates suction that drags abrasive into a mixing chamber. The particles collide, align, and then shoot through a focusing tube. It's basically a microscale particle accelerator. Water supplies the momentum, and the abrasive becomes the blade. To melt metal, you need sustained heat input. A water jet spends most of its energy as kinetic energy, motion, so the dominant effect is mechanical damage, not heating. Any heat that appears is brief and localized, because the water is always flowing and carrying energy away. Now zoom down to the microscopic level. Each abrasive grain hits like a tiny hammer and chisel. It creates microcracks, plows grooves, and knocks loose fragments smaller than a grain of dust. Multiply that by millions of impacts every second, and the cut advances. No melting required, just controlled, high-speed erosion. And water is an aggressive coolant. It has a high ability to absorb heat, and the stream continuously refreshes. So even if friction creates some warmth, the water removes it before a large heat-affected zone can form. That's why water jet edges usually avoid the warping and metallurgical changes you see with heat-based cutting. This is the big advantage: you can cut materials that are sensitive to heat, hardened alloys, laminates, composites, and coated parts, without burning paint, softening heat-treated metal, or causing big thermal distortion. In many shops, water jet is the go-to choice when you want precision without thermal side effects. But it's not magic. Water jets can be slower than lasers for thin sheet. Thick cuts can show a slight taper, and you may see striations where the jet loses energy. The abrasive becomes slurry you have to manage. And the nozzle wears out, because the same erosion that removes metal also gradually erodes the components that guide the jet. Here's the clean mental model: laser and plasma remove material by heat. Water jet removes material by mechanical abrasion, a controlled sandstorm traveling at extreme speed. One method melts material out of the way. The other method breaks it away while staying relatively cool. So water jet cutting doesn't melt metal because it doesn't need to. Abrasive particles do the cutting, and water carries heat away fast. Now tell me, what should we break down next? Laser cutting, plasma cutting, or EDM?